T minus 30 seconds. T minus 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Fuck you, Westport! Westport going to weed! Westport going to weed!
Hey everybody, Chad Westport here, and we are back with more episodes of Cannabis in Your Body with Dr. Miyabe Shields. How are you doing today?
I'm doing good. How are you?
I am doing excellent, and thank you for coming back. You know, it has been a popular series. I've had a lot of people, can you ask her this? Can you ask her that? So I appreciate you coming back for more, but I'm selfishly starting off with my own questions.
All right, hit me.
All right. So in the previous episodes, you had mentioned that, cannabinoids work as retrograde signals and travel backwards from the postsynaptic side to the presynaptic side. Now, all those big words fascinate me, but the first thing was it works as a retrograde signal. Can you maybe explain what that is and the frequency of things we see working this way?
Yeah. So to my knowledge, the endocannabinoids are the only retrograde signalers in terms of like major neurotransmitters being like molecules that our brain uses to talk to itself. And when we say retrograde, we mean backwards. And the big words there, postsynaptic and presynaptic, they mean post and pre, like after and before, right? Like you have like a post dinner drink is afterwards, right? Versus like a pre-dinner appetizer is before. So postsynaptic and presynaptic, it's before and after the synapse. And the synapse, and I was always taught in biology, it never left. I taught that the synapse, like synapse, is where two brain cells meet.
Okay.
So that's the synapse. So when you're saying postsynapse, you're saying the one after it meets. And if you say presynapse, it's the one before, because almost all neurotransmitters, so with the exception of the endocannabinoids, but like serotonin, dopamine, like GABA, glycine, initially when we were first researching them and discovering them, we found that they all signaled in one direction. It was like a one-way street. So everything, when you have a brain cell, it's kind of, if you think about it, it's like trees and roots, right? Or like branches and roots, if it's like a tree. If a brain cell was shaped like a tree, the branches with the leaves and stuff, that would be like the receiving end. And then the roots would kind of be that, I should reverse that because trees take in stuff from the roots. So the roots would be the receiving end. And then the branches and the leaves would be the sending end. But it's kind of like a one direction thing in our brain cells where we receive signals and send signals in one direction. If a brain cell is going to like say send a serotonin signal, it will get activated like at the roots, and then that signal, it's called an action potential, will go all the way through the brain cell and then up when it's at the leaves. When it's at the sending side, that is when it will release the serotonin. Now that one is called pre-synapse because it is the one releasing. And it will be right up next to another brain cell that will receive that serotonin. So it's lined up kind of like branches to roots, right? And then that receiving side, that's called the postsynapse. So everything goes in one direction. And the reason why the endocannabinoid system is retrograde is because it goes in the opposite direction of everything else.
Why? I mean, that's kind of an odd thing, right? Is there an answer to why? I love open-ended questions.
I feel like you're asking like the greater powers that be, like why is life life? No, so it's interesting. Like my leaning towards answering that is that something had to be. Okay, so
good answer too, though. Chaos theory.
I mean, it's just a theory, but let's see. Okay, so all of these systems are ancient. They've evolved from when we were a single cell and we didn't have to communicate to one another. And it, over a long, long time, they've evolved different roles for one another. And these systems have evolved. And when you look at how everything else is kind of going in one direction, like let's say, for example, if it was a telephone and you had telephones lined up, listening end to speaking end, listening end to speaking end, and one of those telephones is being too loud or it's talking too much, you need to have a way to go the opposite direction and tell it to be quiet. you have to
Okay, right.
you have to find a way to regulate it. And that's my opinion for why the endocannabinoid system is the most important system. I'm biased, right? I've studied the endocannabinoid system. It's my obsession. But that's one of the reasons why I think it's the most important, because it's a major regulator. It's like a master controller of some of these other systems. It's not to say that they don't all participate within one another, but in general, the endocannabinoid system is responsible for regulating the activity, specifically like the overactivity or the hyperactivity of other systems.
And so is that kind of how THC and like CBD and basically any cannabinoid works through the system? Is it's going against the flow to alert another system that, be quiet or tone down?
Yeah, it's hard to, so in terms of THC and CBD, like when we take what are called exogenous molecules, things that come from outside our body, versus anandamide, right, which is endogenous, the endocannabinoids from within. When we take molecules from the outside of our body, they're not necessarily going in any direction, because they're just sort of they go from our blood and then they enter our brain and then they're just interacting with what they interact with. But what they do in terms of quieting, and it's called inhibitory, actually,
Mhm.
is the
Okay.
the technical term for the type of activity that they have. Although for CBD, it's complicated because CBD also interacts with the serotonin receptor and it turns it on. But this is what they're doing. They're acting upon these receptor systems and kind of hijacking our natural reason for having them, and mimicking. They mimic the things that our body makes already. So it's almost like they're tricking our body into thinking that there's anandamide here or there is serotonin here.
And you've mentioned the serotonin receptor system, and you've also mentioned dopamine. Now, with cannabis, I will just throw out THC. A lot of people will associate that with like a happy feeling that serotonin produces, and there's a lot of prohibitionists who think dopamine, dope, heroin, marijuana, all the reefers. So they're actually separate systems. Does cannabis, or how do they interact, like cannabis and serotonin, or do they interact?
They definitely do interact, and the systems interact. So when
Okay.
we discovered all these systems, we separated them based on what their like number one thing that they interact with is, right? So the endocannabinoid system is named that way because the number one thing that we found that interacted with it was THC. And just like the opioid system in our brain was like the word endorphin, which is what interacts with the opioid receptors. Endorphins we make, right?
Mhm.
Like we make them. It actually stands for endogenous morphine.
Oh, wow.
It's like a shortened version of that. A lot of the early discoveries of neuroscience were done through the active molecules that we had from plants. And then with the serotonin and dopamine receptors, they were some of the earliest things that we characterized. And they were named that way because that was the primary thing that they interacted with. But the more and more we've researched them, the more that there's this like heavy overlap. So different parts of the brain, you're going to have different receptors that are there. You're going to have they are systems in that not all brain cells have all of them. So some parts of your brain are going to have more serotonin receptors. Some parts of your brain are going to have more dopamine receptors. Almost every part of your brain has endocannabinoid receptors. Um, but it changes depending on the type of brain cell, because we have more than one type of brain cell, the the part of your brain, etc. And how cannabis interacts with these other systems is really complicated, and we're just in the very beginning of understanding that, because we used to study, how do these molecules directly attach to these receptors, which we also call them targets. Like the molecules have targets in the body. And we used to study just that, like how do these molecules interact with these targets? But what we've found is that actually there's all of these downstream effects that happen. An example of this is like if you modify the serotonin system by taking an antidepressant, an SSRI, you will change your endocannabinoid system. Usually it leads to higher levels of endocannabinoids. And
Wow.
there's a bunch of different crosstalk. This is called a crosstalk between the systems that are, in the very, very infancy of being evaluated. We know that it exists, and we know that it exists in a way that is both universal, in that all of us have some forms of crosstalk, but it's also likely that it's highly individualized. There's a couple early papers on changes in serotonin system receptor densities when you chronically use cannabis. And there's a couple papers on specific, I believe that it's specific subtypes of serotonin receptors too,
Okay.
which the interesting one is it's the psychedelic ones. So that always was interesting to me, since there's, a synergy there.
We
But
have receptors, is what I just heard, but I'm sorry, carry on.
I was sorry, 2A and 2C, those are the two that are linked, and they've been shown to actually combine with the CB1 receptor, and then when they get this combination, they signal differently. And this is called heterodimerism, hetero meaning
Yep.
different, dimer two. And again, this is all stuff that's very early in terms of how does this mechanistically even make sense? And we are reaching a point in our technology and our ability to actually see these, slight and minute changes, because we're zoomed in so small right now. I
Mhm.
mean, I think like the amount that I can stress of like how minuscule a molecule is, it's hard to conceptualize, like the millions that would go into it, right? Like if you were to take me and make me as tall as an Eiffel Tower, then a single cell in my body on average would probably be the size of like a screw head,
Oh,
like,
geez.
right?
Yeah.
Very, very small. And then if you were to take that screw head and blow that up to be the size of an Eiffel Tower, then the receptors would probably be like a sheet of paper or something like that. Yeah, they're very, very tiny. And I've done the analogy with like the earth and the world before too, and I believe it's that the receptors are about the size of a yacht. But the problem with that analogy is that some people are ridiculous and have ridiculous sized yachts, so that analogy doesn't always hold up.
Bezos does not apply. But that,
Uh,
that actually, that confirms the analogy I had in my head. Because yeah, when you're looking at things over time, the technology always increases, and you're able to go infinitely closer and closer and closer. And that's when you discover, hey, that one thing is 100 things. Those 100 things are a million things. And we could obviously apply that towards our body and these systems as well. But I do find it fascinating that there is an interaction kind of between all of them. And I know I'm going to have a question in the future about the serotonin levels and cannabinoid presence. So, warning.
yeah, I mean, I'm gonna have to do some digging to see if there's been more recent studies that have been done on it, but it's very difficult because we don't have a good baseline, let's say,
Mhm.
um for like like many people have differences in different expression levels, we call them, of all of these receptors. And there are so many variables that go into when they're expressed and where and why, because our brain is always turning things on and off. Like I think I'm I say it all the time, like we are always in transition from what we were 1 second ago to what we're going to be 1 second from now, from what we were yesterday to what we're going to be tomorrow, from what we were last week to what we're going to be a week from now. Our brains and bodies work on many, many different time scales to be adapting.
So would that mean that the level of CB receptors in our body is really kind of a constant state of flux? It's never fixed?
Pretty much all receptors are always being recycled, same as like our cells, right? I mean, like, when you exfoliate your skin because your skin cells die. And it's in a similar fashion that our receptors are not like infinite, and they're not immortal. They get recycled. They get it's called endocytosed. They get drawn back within the cells. They get broken back down into their basic parts, and sometimes they get put back together and put back up, and sometimes they don't.
Geez, another way that soil and the body are similar. That is awesome. I love the connection
It's
here.
a resource. It's a resource tool.
Yeah. Well, talking about endocannabinoids in general, and with the serotonin and dopamine, you have also mentioned the endocannabinoid dome previously, and you kind of touched on a little bit of it, but maybe can you expand what that meant to you and how that I don't know, would relate to us as individuals?
Yeah, I think the best explanation for that would be the TRPV1 receptor specifically, and its name, I always want it, TRPV, transient receptor potential vanilloid receptor. So it has a very unsexy name,
I'll take your
but
word for it.
it is the receptor that is responsible for spicy peppers. So if you like spicy, specifically like jalapeno, habanero, but also like ghost pepper, like
Yeah.
hatter, like the hatter peppers, chocolate peppers, like the capsaicin that's in those peppers that's spicy is responsible for activating the TRPV1 receptor. It also interacts with endocannabinoids, and it's also been shown to interact with some of the rare cannabinoids. And there are a couple other in that same family of TRP. So the TRP families, because there's TRPA, there's TRPV. The TRPVs, I think 4 is another one that's been shown to be involved with endocannabinoid signaling, and this one has to do with energy metabolism. They're these really fascinating receptor classes. They're huge. They're not the same as the cannabinoid receptors, and they measure a lot of different things. So, I always equate them with the spicy of chili peppers because people have experienced what it feels like to activate the receptor. If you've ever eaten anything spicy, like that is what is happening. And that receptor, though, is in your brain, it's in your body. It plays an important role in pain sensation. And it does more than just that. And I think it's part of the endocannabinoid dome. Now, there's other proteins in the body. So we talk about receptors. They are, receptors, you're thinking at them as like little machines, right? Like little, like they're small, tiny, microscopic things in our body that are doing tasks for us, essentially. There are other things, other proteins, other targets for drugs in our body that aren't receptors. There are enzymes. Enzymes are best known as like metabolizers. So for people who've ever gotten a prescription and it says on there, like, do not drink grapefruit juice with this, that is because grapefruit juice has a molecule in there that interferes with an enzyme. This enzyme is the one that is responsible for breaking down the drugs. It's called the CYP enzymes, and it's a big family, and it breaks down most drugs. So if you have grapefruit juice and it stops that enzyme from breaking down the drug, then you might end up having too much drug in your system. And that's why they say not to do that. So there are enzymes within the endocannabinoid system. The main 2 are MGL and FA, but there are these other enzymes that are, so I researched one called ABHT6, another very unsexy name. There's ABHT12. There's all these other little machines that are tangential, that are performing chemical reactions that are part of the endocannabinoid system that, aren't usually given that priority of saying, they're the central part of the endocannabinoid system. They're usually more often referred to as, part of the endocannabinoid system, or, interacts with the
Right.
endocannabinoid system. And it becomes difficult when you are trying to say like, oh, this is part of this one system. And yet so many things in the body interact with many, many things. There are carrier proteins. They're little baskets. So, you know how oil and water don't mix,
Yep.
right? You know how cannabis and water don't mix? Well, I mean, all the bubble hash people are going to be like, I mix it all the time. And it's like, yeah, but you don't, right? It doesn't dissolve. Like the cannabinoids don't dissolve in the water.
Right.
And so you have to have things in the body that transport those molecules around, because we are mostly water. Like our bodies are made up of mostly water. And so there are these little basket proteins called fatty acid binding proteins, FABPs. And, they've been shown to shuttle around both endocannabinoids and phytocannabinoids, like CBD, THC. They're not necessarily included in part of the endocannabinoid system, though, because they shuttle around other things too, right? Like, so that's kind of what I was saying when I was mentioning the endocannabinoid dome. I was kind of just describing all of the things in the body that potentially interact with the endocannabinoid system or with cannabinoids, and that there are these other sort of support aspects of the endocannabinoid system that are shared across a larger, space of fat signaling and fat metabolism, and really just the fatty things in our body. But there's still stuff that's getting discovered today. I mean, we're still, it's a really exciting time. We're doing more research on cannabis than ever before, and that's awesome. And like,
yeah,
oh, sorry, go ahead.
and in a meaningful way, we're not just looking for damaging results. So
Exact
that's a plus.
for the first time pretty much ever.
Yeah,
Like,
that huge plus.
yeah, exactly.
That's that's interesting. I didn't really consider how they move through the system, and that we are mainly water. And again, that brings me back to the farming side, which I know it's like chelators for nutrients, certain nutrients. It actually like encapsulates them and allows them to get into the plant and move around. So it's like we've got natural chelators.
That's really, really similar. It's like a bigger thing than that, right? Because chelators are for, if you imagine chelators being for like one ion, right? Like a metal or a nutrient. This is like the THC molecule is huge. I think it's over 30 something. Maybe not. It's like 23. It's a bigger though than one ion. So if you imagine it, instead of it being like a chelator, of it being like, but it's the same thing. It comes and it makes the outside able to be transported while the molecule is kind of like safe within. It's very similar to nanotech, actually. Most of the nano emulsions and nanotech stuff that you see with like the quick onset and that sort of stuff is done in a similar way. They either create small little particles where the cannabinoids are inside, or they bind it to something like a sugar or something, and that is how it gets dissolved.
That's interesting, because I always like to be a naysayer of things. Of like, that's marketing. But that's one that I have personal experience with, that I felt I was like, I think there is something different to it. I do notice something different. So that was an interesting one.
I do, and there are differences between. I was laughing about it. Riley and I were laughing because we're like, everyone has a salad dressing story, right? Like if you've ever tried, right? If you've ever tried to make a salad dressing with cannabis infused olive oil, you like surprisingly end up, overdosing yourself.
I'm gonna
But it's
cry over
because,
here.
salad dressings are emulsions. So they're not nanoscale, they're like micro scale, they're
Okay.
bigger droplets. But oh man, I'm pretty sure everyone has a salad dressing story. If not, when you try it out, be careful, because it's an emulsion.
I take that as a personal challenge. So
You have to get back to me on it. Like,
yes.
no, it's like olive oil and anything for the most part, but the like immersion blenders, I mean, then you got an emulsion right there. I mean, it'll re-separate itself out over time, but
Right.
um
I'm gonna loop this and go into the kitchen. Oh man. Now, sorry. That's dangerous.
okay.
So getting back to the studies, though, you were kind of talking about, we're able to do positive studies. Have there been any studies that you've recently found since we've last spoke that you're just like, gosh, this one's interesting?
You know, I've seen quite a few, but some of the ones that are really sticking to me have to do with like differences in like there's been one that I saw was a poster session, so it wasn't a formal publication, but it was a quantification of new molecules that were only in outdoor grow, and it was done with
Hmm.
clones.
Wow.
So essentially it was like taking clones and growing them in, similar conditions, but you cannot replicate outside. I mean,
Yeah.
that's kind of the whole point of the study. And it was fascinating because it was, just it's very preliminary. But it was something that I mean, most people are familiar with it. And there's one other study that was done pretty recently that was also showing that like heavier terpene development, more in different terpene profiles in outdoor grows. And that was like a kind of rabbit hole that I went down for a little bit because, I do prefer it. Just personally, not that there's anything against indoor grows. I also like think that that's incredible, but the feeling tends to be more mellow in my opinion. And,
Mhm.
I was also I was also going down a dive of there's some more interesting conversations coming about now too when it comes to cannabis use disorders, like what qualifies as a cannabis use
Right.
disorder and what demographics. And there was one paper, and it's not necessarily it was just interesting to me. It was studying medical students, and it said that surgeons or people who were going to become surgeons were more likely to be alcoholics or more likely to drift towards alcohol, and primary care physicians or people who were interested in being
Wow.
primary care physicians were more likely to use cannabis. And it was, it was just like one study, but I was like,
That's awesome.
that's like that was just such an interesting divide, and fascinating just because it was medical students, and it was, I think the cohort was like followed for like 4 years.
Mm.
But I've always in my mind known, there are like there's a funny post I saw where it was like, yeah, can we get less stimulant people in politics? Let's dial down the stimulant type people that are in politics, and let's get more of the weed people in politics. And it's like, meanwhile, the weed people, we're all just like chilling, and we're like, we don't want that
We're
involvement.
good.
No, I just thought that study was interesting for that reason. Not saying that I dislike people who don't use cannabis. That's not what I'm saying whatsoever. I have
No.
friends who don't use cannabis, but not many.
But I'm sure that we both agree cannabis isn't for everybody, but it's for a lot
No,
more people than are aware of it. So that's
I
why we
mean,
do this.
absolutely. It's nothing is for everybody either. I mean,
Yeah.
like we're all so individual, and we
Yeah.
have really, really by the time that we're older, we've gone through a lot of experiences that change the way that we respond to these molecules. So we were and when we were naive to them in the very beginning, when we've never taken them, it's very different from now, right? I mean, my
Yeah.
brain is like 18 plus years in. Like
Same.
there's no going back there. And I'm not under any, delusion or illusion that it hasn't had an effect on, how my brain developed and how it continues to develop. I'm just in the mindset that there are pros and cons to both of those things. And for
Yeah.
me personally, like I am like on my own personal self positive it was positive. That's not to say that that's not true for everyone and other people. And things change and your life changes, and you could potentially have a hormonal change, you could have a life event happen, you could have different stressors come on in your life. There are tons of reasons why that could change or why situations could change for you. So
Well, this has been an awesome session. I know I'm looking forward to more. We've got a couple already planned and in the works, but I'm sure this has spawned a few more because fascinating stuff today, Miyabi. Thank you so much for your time.
yeah, looking forward to catching up.
Yep. And everybody, all of her contact information down in the show notes. Definitely go to the website, join the secret mailing list, and you'll get updates. So be sure to do the mailing list on her website. Instagram is down there as well. But until the next episode of Cannabis in Your Body, we will catch you later. Bye-bye.
Westport.